Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 26th. First up, we'll take a quick look at the North Pacific Ocean. Little area, wind swell here, pushing towards the Hawaiian Islands, is in play right now. Roll that out. Should hit the islands by Monday, creating some fun north angled swell, wind swell really, but nothing in particular of interest. We roll this out, just nothing's going on. A bunch of wind swells scheduled for the U.S. West Coast, mainly in the area of California. Strong gradient building off of Cape Mendocino with up to 30-knot winds on Wednesday and Thursday. And then another little gale is forecast for the Gulf of Alaska with 22-foot seas, maybe. It was higher the last run of the model, up to 26 feet. But again, all aimed at the U.S. West Coast. Seems kind of a reach by the models that it would even get that big this late in the season. But who knows? Maybe a little bit will happen from it. 13-second period swell for the U.S. West Coast, but not a lot of size. And then that's pretty much it. But looking down into the southern hemisphere, it is a totally different story. A strong storm is currently pushing across the deep South Pacific Ocean, generating 53-foot seas aimed well at South America, with sideband energy pushing up into Central America and towards the U.S. West Coast. This is the system that we should be watching. So let's start our tour. Jet stream level winds. These winds, up about 30,000 feet, help support the formation of storms, and when those storms do form, help direct their track. Currently, right now, we have a split jet stream pattern over the southern hemisphere. But there is a bit of a trough forming here in the southeast Pacific with 120-knot winds blowing up into it. This trough is what is supporting a storm currently down at the ocean surface. But notice South America protected by a strong ridge at this point in time, and almost hints of another trough trying to develop in the Tasman Sea. Let's put this into motion. As we move into Monday, the trough continues east. Another little trough, again, tries to form under New Zealand. Not quite doing it, though. Anyway, this trough remains solid. More winds blowing up into it by Tuesday, 140 knots. And that pushes on to the east, and then finally a big ridge starts developing, while a new trough here on Wednesday starts to develop just east of New Zealand. Actually, put this back here, and its peak here on Tuesday night, 130-knot winds filling up into it. This, too, could support gale development at a minimum. Anyway, that trough sort of fades out, starts pinching off, but then another pocket of wind starts developing on Thursday under New Zealand, and sure enough, it starts feeding the redevelopment of this trough, again supportive of gale development into Friday, and then even into Saturday, and yet more wind energy starts working its way up into the trough on Sunday, and then we come to the end of the run. Again, a fairly favorable pattern for the southern hemisphere. Compared to the northern hemisphere, there's nothing going up there. The whole focus is down south now. Summer has arrived. Next, we take a look at surface level pressure and surface level winds, and something certainly catches our attention right off the bat. A strong storm with 55 to 60 knot winds. 65 knot winds would be hurricane force, and in fact, the system was originally forecast to have 65 to 70 knot winds, so it's comparatively wimped out compared to what it was, but still 55 to 60 knot winds over a good size area, aimed pretty well at targets in South America. We put this into motion. Notice the fetch lifts to the north. Good sign here. It's not just going flat west-east, but it's actually pushing up this direction towards South America and even the U.S. West Coast for that matter. 50 to 55 knot winds into Sunday night, and then slowly it tapers off into Monday night. But still, a solid system, certainly capable of generating swell. And then here we go. Remember, there was another trough off New Zealand on Wednesday. It starts forming 45 knot winds, a little tiny area of 55 knot winds, again aimed well north. That will hit all the South Pacific islands and also up into the U.S. West Coast well, though it's not nearly as large or strong a system as the previous one. Anyway, remnants of that system peter out into Thursday, but then notice another just consistent fetch. High pressure here, low pressure here, pressure gradient or difference in pressure between the two because they are in reasonably fairly close proximity. You get winds generated, 35-knot winds over a pretty good size area. Continued swell development possible. And here we go again into Saturday. Another nice little fetch of up to 50-knot winds, aimed pretty well to the north. And yet more fetch behind that. The southwest swell corridor relative to the U.S. West Coast and South America appears to be open. This is a very good sign. Next, let's take a look at the effect of those winds on the ocean surface. And we're going back in time, 18Z Saturday. So roughly around 10 a.m. Saturday, U.S. West Coast time. 30-foot seas developing in association with this new storm, and it's actually just southeast of New Zealand. Anyway, quickly develops by the Saturday evening, 46-foot seas, and then 50-foot seas as of right now. This is current time, 18Z Sunday, and expected to build a little bit more past that, maybe 54-foot seas or so forecast by this evening. All aimed well towards mainly South America, but good sideband energy. In fact, we could do this right now. Northern California, what's that? About the 190-degree track at the peak of the storm. Southern California, about the 192 roughly. And Hawaii, though, unfortunately, all the energy is cutting completely perpendicular to the Great Circle paths up to the islands. Maybe just the littlest bit of sideband swell from early in this system. Costa Rica, good energy. Look at that. Look at the arrows pointed right up the Great Circle paths to Costa Rica, to Peru, and that's about, and certainly we don't have any Great Circle paths here further south, but also these areas as well. Most impressive, good solid storm, large swell working its way, assuming it develops as it's forecast. We're only 6 hours off from that, so the assumption is the swell is already in the water. Anyway, we roll this out, see what's coming behind. Notice it holds together pretty well. Even into Monday night, we're still in the 44-foot range for seas, and then it starts decaying. The wind's actually gone by then. This is mainly just the seas previously generated from previous fetch decaying as they work their way towards South America. And then we can continue out. Here we go. Here's this new little gale that we saw on Wednesday forming. Now notice the size of this. Nowhere near as large as this other system here, but still 40-foot seas, small area. Certainly the South Pacific Islands will do well. Hawaii will do well. And of course the U.S. West Coast will get some energy from this. And that one's a much shorter-lived system, but pushing well to the north. And then more fetch behind that. Here we go, 36-foot seas forecast on Saturday. That's almost a week out now. Aim north, and again, a very small area. And more behind that. So certainly plenty of background plus energy, and then some after the big swell already hits. Very favorable pattern for this time of year. Looking good. And of course, we have some data to actually verify how well this storm is doing. JSON-2 satellite track. Multiple tracks, one of them going right over the core of the storm. Notice it's actually broken up a little bit. That suggests there's a lot of rain. Couldn't get good measurements, but the measurements we did get, so max average measurement, this is 15 measurements, and these are just little tiny slices here, not very long at all. 43 feet with one peak measurement to 46 feet in where the actual wave model suggested wave heights were in about the 44 to 45 foot range. The suspicion is there was much higher seas that were not recorded by the JSON-2 satellite due to rain obscurity. So this is actually tracking very well to the models. So our belief is the models are pretty much right on track with what this storm is doing on the ocean surface in terms of fetch blowing, generating seas, etc. So we're building confidence that this is a legitimate depiction of what the storm is doing and not just a mirage. And yet, one more pass at 12Z. This, now again, out on the outer periphery here, 36 to 42-foot seas. You can almost see it right in here. That was actually at 63 and 154. That would have been more about here. Okay, the wave model showed or depicted about 34-foot seas or so, maybe 36-foot seas. We have a 15 reading average of 36.3 feet with a singular reading of 42.7 feet. Again, building confidence that the model is right on track. And yet one other pass out here, I mean, way out in the periphery, but it reads well. This is 26-foot seas. That's exactly what the Jason 2 satellite is showing. Even little hints of 30-foot seas in there. So very good. The model is doing an excellent job this time of projecting and managing this storm. And yet one more model view. Now this takes into account the effect of actual sea heights and swell period and integrates it to create a rough estimate of surf sizes if there were land, if the swell was actually hitting somewhere. Here's our big storm, of course completely off the charts, not believable, and the other smaller system that preceded it here. We can put this into motion. It's sort of like the period charts that people look at, but instead of looking at period, you're actually looking at surf size as it works its way towards any given landmass. And here we go. So let's just say roughly South America, in this area, on roughly the Thursday time frame, white is 38-foot surf. And decaying, you see the size decay as it moves away from the fetch area, but still a very respectable surf forecast for this area of the South American coast in the 30 to, let's say, 35-foot range. And we can zoom in on other models, but we're not going to do that right now. You get the general idea. And also notice here, we're going to here relative to the U.S. West Coast, and here's kind of an interesting way of looking at it. So Tahiti's right out and about here. You can actually see the effect of the Tahitian swell shadow here. See that? It's complete blockage in that area. But because the bulk of the storm is unshadowed relative to the U.S. West Coast, energy can push north for the most part unimpeded. And look at that. Just moving right up. The shadow is like a hard wall right there. You also get to see the effect of the Galapagos Islands on Central America. Look at how pronounced that is as well. So this is an interesting tool, something to look at. Anyway, we're going 130 plus hours out, and things sort of fade out there. Look at the shadow, very pronounced. Anyway, plenty of swell making it past the Tahitian Islands here relative to the U.S. West Coast. So roughly Northern California is at about 122 here. So plenty of energy headed that way. And then yet more, here we go, the next round coming right behind that. Again, here's your shadow in effect, but plenty of energy. Very good looking pattern for now. Next, we take a look at long-term patterns. What's going on with El Nino, La Nina, the MJO, the Southern Oscillation Index. That's what we're checking out here. Difference in pressure between Darwin, Australia, and Tahiti. Currently, the numbers are pretty much kind of neutral, mixed bag, couple of negatives, couple of positives, not a whole lot going on, suggesting neither the active or the inactive phase of the MJO, 3.80. The 30-day running average working its way up. It was down at almost minus 10 or more. Now it's up to minus 2.98. And the 90-day running average, which has been in the minus 7 range for months and months and months, is now starting to rise, minus 4.52, perhaps suggesting that the El Nino we thought was developing maybe isn't quite as mature as one would hope for. But the Southern Oscillation Index does not tell the whole story. It is actually winds or anomalies. That's what we're looking at here. Differences in wind speed and direction for this time of year for this location of the ocean. And specifically, we're interested in the area right here, north of Australia into about the international date line. This is what we call the Kelvin wave generation area. Westerly anomalies in this region, when they're present, help to form Kelvin waves. That is, when trades relax, and that's what this is, a relaxation of trades or out-and-out westerly winds, allows warm water, normally here, to fall to depth and start pushing its way east under the equator, the whole way across the Pacific Ocean, and eventually that warm water starts gurgling up near the Galapagos Island, and that is how El Nino, or at least one of the ways in which El Nino gets formed. Anyway, we see, in fact, a relaxation of trades, nice, modest westerly anomalies in this area, and then we continue looking east, and sure enough, those westerly anomalies continue to a point about south of Hawaii, a little bit more, then they fade off. This would help support the formation of another Kelvin wave, or at least feed the Kelvin wave that's already in flight. So that was a model. It's actually a model that's up at the 850 millibar level, about 4,000 feet up in the air. What really matters is what's going on down at the ocean surface. The good news is there are buoys strung the whole way across the equator that can be used to measure not only sea temperature here, but also actual wind speeds. And you see trades, of course, are in effect along the equator. But notice here, off right in the middle of the Kelvin wave generation area, little bits of actual westerly winds blowing. Maybe not very strong, but certainly no trades. Again, this supports the formation of Kelvin waves. And here we go, actual westerly wind anomalies. Here, this is the anomaly data. Also notice water temperatures here. 1 degree above normal the whole way across the equator. 1.5 degree anomalies starting to show up near the Galapagos. And then there was a pocket of 1.5 degree anomalies here that was working its way east, and it's just sort of disappeared now. The interesting thought is this pocket of really warm water here had been here for a year or more, and it appears to be on the move. We say appears because there's no real clear indication. But if it is, in fact, on the move, and warm water on the surface is moving to the east, as well as warm water at depth, then that shows a potential coupling of the atmosphere. This only happens once El Nino actually gets its legs going, and you'll see the Walker circulation, what normally would be trades here blowing this way, all of a sudden there's a break in the cell or a change in the cells, normally way over here. So you have trades going the whole way across the equatorial Pacific. But then what will happen is the break in the Walker cell, and maybe call it right here, is you'll get westerly winds on this side, easterly winds on this side. That's what appears to be happening. And when you have consistent westerly winds over time, or at least anomalies, warm water that's here starts working its way towards the Galapagos Islands. So we don't have any hard evidence yet. There is a little pocket here, you can see the yellows, that suggests it's somewhere down south. The core of the warm pocket that was way back here is now somewhere south of Hawaii. Something to follow and look forward to in the days ahead. Anyway, continuing our tour, a week out, we look at the models. What do they say in terms of westerly anomalies? Sure enough, building westerly anomalies on the date line, actually from the maritime continent, weak, but building solidly on the date line, and on getting a little bit of traction down to the south too, and then continuing to a point south of Hawaii, and then fading again. Again, that sort of suggests that the perhaps Walker circulation, the changeover in the two cells, is maybe somewhere in this area. Not guaranteed. There's a lot of other factors that could be causing this as well, but still something to monitor. Again, we'll examine this chart. So the yellows and oranges represent westerly anomalies, and we have a little bit of forecast here. So the West Pacific is roughly over here, the East Pacific roughly here. We look back in time, there's been just massive westerly anomalies, out and out 25 plus knot westerly winds in the West Pacific back earlier in March. Things have settled down a bit over time, but notice there's still consistent westerly anomalies, and then maybe a week out, a little bit stronger westerly anomalies, again forecast in the dateline area. All this suggests is that there is still good support for Kelvin wave development. We need this, especially come about the June or so time frame. Last year we had a massive Kelvin wave develop, followed very similar to the Kelvin wave that's in flight right now, and we'll get into the details in a second. But you know what? There was nothing behind it. Westerly anomalies backed off, and that was kind of it, and or what we thought was a major El Nino developing just died off. So the June-ish time frame is where we're looking to see westerly anomalies redevelop, start pushing more warm water to the east. We won't know it till it happens. Right now, we're still in the spring unpredictability barrier. That will continue until about mid-May, end of May. Once we get pretty deep into May, we'll start getting a sense of what's to come, but it won't be till about the middle of June that we really know where we're at in terms of, let's say, the fall time frame. For now, we're looking for the presence of the MJO, and we see absolutely nothing. Another hallmark of El Nino. The MJO fades out completely. Westerly anomalies continue, which are typically associated with the active phase of the MJO. But when you get El Nino, you get no MJO activity, but you still get the westerly anomalies. The forecast per the statistic model suggests basically a dead neutral pattern, a little bit of the active phase trying to organize in the Indian Ocean, maybe seeping out, but this model suggests basically not a whole lot going on. The dynamic model, again, suggests a very weak pattern, but instead of the active phase developing in the Indian Ocean, it says the inactive phase. So who knows? It's anybody's guess. This is 15 days out, but at this point, the models definitely are in sync of a weak pattern in play now and expected for the next 10 days. The upper level 40-day model also suggests very much the same. Maybe a weak active phase going on. The greens are supportive of precipitation, which one would typically associate with the active phase of the MJO, and through about the middle of May, whatever that is, if it's not really the active phase, but support for precipitation fading out, moving into Central America, then perhaps a weak inactive or area not supportive of precipitation from about the 1st of May until about the 3/4 of the way through May, and then another weak active phase behind that. But all this is just pretty much neutral, nothing, not a strong pattern at all. Next, we take a look at surface level temperatures, and the charts continue to look good. Warm water along the Peru and Ecuadorian west coast, above normal. Warm water along the equator, the whole way across the equator, but certainly around the Galapagos. Here is that one warm patch. It's interesting, the TAO data doesn't really show it. It just shows sort of a continuous temperature pattern the whole way across the equator, but there clearly appears to be a larger bulge of warm water in this area here. But it is east of the date line, not quite south of Hawaii though, somewhere in this area. It had previously been back here. We think warm water is on the move, as we've said before, but there's not hard evidence of that yet. Something we're watching and monitoring. We'd like to see it. That would suggest that we're moving towards El Nino. Of course, there's all the warm water that's in play all the way up here off the U.S. West Coast. This is standard fare. And just for laughs, here's the chart from last year, exact same time, just a year back. Notice warm water, and here's the warm water we were talking about, roughly 160 east to 180 in this area here. But notice no real warm water along the Peruvian coast. Let's flip back. Here's where we currently are. Much warmer water here. Much more warmer water across the entire North Pacific. Back and forth. Notice the change. We are in a much warmer regime, that's for sure. The question is it going to build and be really warm in this area? It needs to come up still another 2 degrees or 1.5 degrees to really be El Nino, so we've got a ways to go. Next up, subsurface temperature profile. Actual water temperatures, and notice warm water here. It's the gradient or the slope here between, if you're in La Nina, you'll have all kinds of warm water at depth here, and it'll get very, the warm water layer will be very shallow in the east. It's not bad, but nothing outrageous. But what we're really looking at is the difference from normal. And notice this large warm pocket, 5 degrees above normal. And here's another little 5-degree pocket starting to work its way into the Galapagos Islands. This is the West Pacific. This is the East Pacific. This is depth 300 meters. Cooler water out here, but warm water, and really right in here. This is the typical Kelvin wave track, and this warm water was all over here. It's working its way in. This is a significant Kelvin wave, one we've been monitoring, working its way across for the better part of 2 months now, 2.5 months, and it is arriving a little bit ahead of schedule along the Peruvian coast. So there was actually, when this warm water pool started hitting and started arriving along the Peruvian coast, notice here's imagery, satellite-based imagery of temperature anomalies along the Peruvian coast. This was back the end of March. Here's where we currently are. It's actually eroded a bit. Still good water up in here. Actually, more water. We'll go back here. Here's the current data. More water up in here, but less water down, warm water down here. This was the peak of it back in March. So we really want to see warm water building up. Actually, here's the current image, all over this area, and we're not seeing it yet. We're wondering, so the same thing happened last year where a massive Kelvin wave formed. It hit this area, but you know what? It never really showed or manifested itself as strong as one would have thought. And we're wondering if that's not going to be the case this year too. If this Kelvin wave erupts here, does what it's supposed to do, and if we were in an El Nino mode, you would think you'd start seeing serious warm water building up in this region, certainly by the late May, early June time frame. So this is not a cause for concern at the moment, but we will be watching it very closely. And yet, one more depiction of the Kelvin wave, this suggesting 5+ degree anomalies, almost 6 degree anomalies, actually definitely 6 degree anomalies. The bulk of the Kelvin wave has not hit yet. We're just the very leading edge is starting to show up in the Galapagos. So we'll see what happens. And finally, upper ocean heat anomalies. West Pacific here, East Pacific here. Assume this is the Galapagos over here. This was last year, May, the big Kelvin wave that hit. Upwelling phase, cooler water. Then here's what happened. We had 2 weak Kelvin waves develop in the summertime, but not very strong. They didn't support a lot of warming along the equator, and El Nino never really formed. Modoki El Nino. And then another upwelling phase, the Kelvin wave. And now here we are, January. A massive Kelvin wave, massive westerly wind bursts in mainly the February-March time frame. Here's warm water on the move, right on the verge of making it to the Galapagos Islands now. So we had forecast the Kelvin wave hitting about March 1st in the Galapagos, and that it would take the better part of a month for it to fully peak out. So far, this seems to be about right. We'll see what really happens. But in the next week or two, we should start seeing warming, and pretty good warming, along the Galapagos Islands if this Kelvin wave is going to help contribute to the formation of El Nino in the 2015-2016 season. And finally, the hype from the CFS version 2 Nino 3.4 model. Here we go. Currently, it is suggesting water temperatures are 1 degree above normal. And the CDS 3.4 index suggests 1 degree above normal. A little bit higher, actually. Temperatures dropping off a little bit in this area. But the model suggests that by July, water temperatures are to be 2.15 degrees above normal. That in and of itself would be a significant El Nino. But that's only the start. By the September time frame, temperatures start going up again. Into October, we're into 2.5 degrees. And by the late November time frame, classic peak of El Nino, we're at 2.75 degrees. If that were to happen, this would be a very significant El Nino. Now, let's put a wet blanket on the hype. This model did the exact same thing last year. Not as high as this. It was up in about the 2.4, 2.5 range. So this is, and of course, that never happened. We ended up with a weak Modoki El Nino with water temperatures down around in this range. So we don't believe this for a second, but it is something to monitor. If this was going to happen, we would start seeing some signs of it, according to this model, in the May time frame. And sure enough, that Kelvin wave is supposed to erupt along the coast in the May time frame. So let's see whether it actually gets traction, whether it starts making this big spike, and whether that spike can hold, whether there's going to be more westerly anomalies behind, and yet another large Kelvin wave develop, or whether the whole thing's just going to fall apart and we're going to do a repeat of last year and end up with a Modoki El Nino in the fall. So who knows? But for now, the good news is a significant storm is in the southern hemisphere. Swell is in the water, pushing towards all the major breaks, but probably Hawaii. And that's good news. And There's more storms projected behind that for the New Zealand area, southwest swell energy, including Hawaii this time. And so that is good news. And there's major Kelvin wave activity in flight, westerly anomalies occurring. So the El Nino hype machine continues. Things are actually looking reasonably positive. We need hard data. The key time frame is going to be the month of June, to find out whether we really get El Nino or whether it's just going to be another fake out and another false start, and we go for the yet maybe a second or third year of Madoki El Nino. Anyway, there's swell in the water. There's going to be surf, so make the most of it. Enjoy. We'll do this again next week, same time, same channel. Go get some surf. See you then. Bye.